This is lesson 18 of Engage New York. The problems involve unit rates and will tie in averages and other problem solving as well. The standard practice problems are pretty similar to what we've been practicing in the past. For example, Aaron earns $12 per hour shoveling driveways. If Aaron worked for 14 hours this month, how much money did he earn this month? Once again, this is showing us a unit rate of $12 to 1 hour, so we have to get that hours to 14 and see what the dollars are. We have dollars, hours, and a 12 to 1 ratio, unit rate. We want to get the hours to 14. Would be $168. Nothing too complicated about that. B is a little bit more challenging, but you're just using the other side of the table. If Aaron earned $210 last month, how many hours and minutes did he work last month? Still start off your table with the unit rate that's given in the problem. But we have to use the other side of the table to figure out how to go from $12 to $210 and find out how many hours that corresponds to. To do that, we can use division. So we have 7. Then we have a 6. And we have to add a decimal point, which becomes 17.5 hours, and that can be expressed as 17 hours, 30 minutes. So that might happen because it's a unit rate, so if it doesn't go in perfectly, that remainder of time he still gets paid for. This type of problem, a quarter weighs 6 grams. How much does $9.50 in quarters weigh? Setting it up with our table, we have a unit rate. So quarters to grams. So 1 quarter corresponds to 6 grams. That's our unit rate, or 6 to 1, whichever order you put it in. We need to figure out $9.50 in quarters. You might be tempted to just put $9.50 into your table. But that's not really what this means, because it's not telling us this is not a dollar value. If we're expressing this in a dollar value, we would actually call it 0.25. And 0.25 corresponds to 6 grams, and then we could figure out to go to $9.50 that way. I think there's a simpler way to do it, though. Instead of getting these to money, which is $0.25, $0.25 to $9.50, we could think about the number of quarters. To do that, we need to think about how many quarters are in $9.50. And that might be a separate table where you can think about, okay, 4 quarters equals $1. So for $9, we're going to need 36 quarters And for another 50 cents, we're going to need another 2 quarters. So for $9.50, that would be actually 38 quarters. So we're actually going from 1 quarter now to 38 quarters, just multiplying by 38. Whatever we do to one side, we do to the other. So that would weigh 228 grams. You could have kept it in going from 0.25 to 9.5, although that is a little bit more challenging of a problem computationally. This last problem is one that we've seen before, very similar. 5 students averaged 94% on their tests. 4 scores are shown below. What was the 5th student's score? First of all, knowing what average is a unit rate. So if we're given average, it's telling us for every 1 student, the score would be 94. That's what average is. It's a unit rate. It doesn't matter if you flip the table. It would be a 94 to 1 student or 1 student to 94 rate. So knowing that, we should also know that the sum for 5 students should be 5 times as much as that. So off to the side, I'm going to do 94 times 5. 5 times 4 is 20. So the sum for 5 student scores should be 470. That's the only way that the average would work out to 94%. So far, we have a sum of 9, 18, 22, 30, 9, 18, 27, 30. So far, for 4 students, we have a sum of 370. So that 5th student, to get that total to be 470, must have a score of 100. Because we're looking at the difference between this, and if they scored 100, then we would have a score of 470. So that 5th student scored 100%. Once again, the sum needed to be 470. We found the sum was 370. The difference there is 100. Those are types of problems, and similar to what you might see on a homework assignment, your questions on the homework assignment might require more application to solve.